So we're going to divide the lectures of spectroscopy up into excuse me please several conversations. In the first one, we are going to talk about the three kinds of spectroscopy: mass spec, infrared spectroscopy, or that's actually spectrometry, spectroscopy, and proton NMR. Okay? And the very first thing that you need to appreciate is, what does mass spec tell you, what does IR tell you, and what does proton NMR tell you? So let me ask you to consider pausing the video at this point and making a guess. What's the main take-home message from mass spec? What's the main take-home message from IR? And what's the main take-home message from proton NMR? Okay? So mass spec is, you guessed it, mass of particles. We oftentimes are going to simply say we're going to find formula weight from that. Alright, IR. Functional groups. And proton NMR is, okay. Now in our second conversation, connectivity, how things are connected. Let's talk about mass spec and how two compounds will have a different formula weight but say the same general formula. Alright? Let me give an example. What about two compounds that have the empirical formula CH2? Right? So if something has the empirical formula of CH2, it could be a carbon with two hydrogens, which would be a problem. Right? We've never seen anything like that. It's a problem. It's octets not filled. There's a few problems with that. The octets not filled and so on. It could be a carbon, two carbons and four hydrogens. That's possible. Right? Or it could be three carbons and six hydrogens. Right? That's not six. There's six. Okay? So all three of these have the same empirical formula, and mass spec is going to tell us which one it is. Alright. IR. Let's talk about two compounds which have exactly the same molecular formula. Oh, by the way, we forgot to say, the molecular formula of this is CH2, right? Of this one, it's C2H4, and here it's C3H6, right? Okay. Suppose then, with another compound, we have two compounds that have the same molecular formula. Let's take C2H6O, but have different functional groups in them. For example, CH3, CH2OH, which is ethanol, or what about CH3O, CH3, with this dimethyl, which is dimethyl ether. This first one looks like that. The second one looks like that. Right? And we could differentiate them with IR. Okay? And then finally, let's think about proton NMR. Two compounds which are the same in every way. They have the same functional groups, the same mass, but different connectedness or different connectivity. How about C5H12? Take a second. Why don't you pause the video here and draw out the structure of C5H12. Okay? So what you might have done is 1, 2, 3, 4, 5. Right? But you also could have done 1, 2, 3, 4, 5. Right? Or 1, 2, 3, 4. No. 1, 2, 3, 4, 5. Right? I think those are the only options, actually. I think there's only 3. 1, 2, 3, 4, 5. But these two are the same thing, so we cross that off, right? Yeah, definitely. Those are the only 3 options, C5H12. And it turns out their proton NMR spectra are going to be different, but their IR spectra are going to be similar, and their mass specs are going to be similar.